LDA will always produce the number of topics you ask for, even when that number is nonsense. Gensim plus coherence scores will reveal cleaner themes and a defensible topic count. You'll see how to connect the pieces into a workflow that compares topic counts and picks themes using a clear quality score. I'm Professor Pi, teaching AI foundations with simple Python. Topic modeling answers a straightforward question. What are the main themes hiding inside a stack of documents? People reach for it when they want quick summaries, exploratory clusters, or light work features for downstream tasks. Gensim is a handy fit here. It gives a compact pipeline that runs in memory, uses sparse counts, and includes scoring helpers so you can compare options without rebuilding every piece from scratch. Think of LDA like this. Each document mixes a few hidden topics, and each topic mixes a few words. You feed it token lists, not raw paragraphs, and it finds word patterns that reliably show up together. It's fast and interpretable for medium-sized corpora. But be aware, rare words can push topics off course, and you still have to choose how many topics to ask for. We'll build one clear pipeline. Train small LDA models across different topic counts. Score them with coherence, then try filtering rare tokens to see how pre-processing shifts quality. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To get started, I will make a tiny readable corpus so you can see what the model actually receives. This snippet prepares a tiny, readable corpus for Gensim LDA. LDA starts from tokenized documents, not raw paragraphs. So the first thing to make visible is what the model will actually see. The docs list has 3 clear themes: space, baseball, and health. Gensim's simple preprocess lower cases and tokenizes each string into texts, giving us a compact in-memory input without embedding models or external files. The output shows the document count and the first few tokens, which matters because bad tokenization can make every later topic look plausible but noisy. Now that we have token lists, the model needs integer IDs and sparse counts. This example converts tokens into the sparse counts that Gensim LDA model expects. The tempting mistake is to think the visible words go straight into LDA. But Gensim uses integer token IDs from dictionary. The DCT object learns the vocabulary, and doctubo turns each token list into word count pairs inside corpus. That representation is smaller and more model-friendly than repeated strings. The output shows how many unique tokens were learned and how many token counts appear in the first BODOC document, which confirms that the corpus is ready for LDA training. Training a single model is fine, but you need a way to choose how many topics to ask for. This code tests topic counts instead of trusting whichever LDA output looks convincing. LdaModel will happily return 2, 3, 4, or 5 topics here, even if some are repetitive or unstable. The loop trains one LDA model per K with the same corpus, DCT, passes, and random state. Then CoherenceModel scores each model using CV coherence from the tokenized texts. Higher passes gives the optimizer more sweeps over this small corpus, while random state keeps the comparison stable for teaching. The output shows the best topic count by coherence, which gives you a measurable reason to choose themes. If the best model still smells like noise, pre-processing can change the story by removing one-off words. This snippet reduces the chance that one-off words dominate a tiny topic model. A rare word can make a topic look specific, but that specificity may not generalize beyond one document. Clean DCT starts from the same texts, then dictionary.filter extremes keeps tokens that appear in at least 2 documents, and removes terms that appear in too many documents. clean corpus is rebuilt because token IDs can change after filtering. The cleaned LDA model and coherence model reuse best K, so we are changing the vocabulary, not the selection rule. The output shows the smaller vocabulary and its coherence score, which makes pre-processing a visible modeling choice. With a chosen topic count and cleaned vocabulary, you can apply the model to new text and inspect mixtures. This example turns the comparison into a small working baseline. After choosing best K and cleaning the vocabulary, final LDA is trained once more and then applied to a new short document. Clean dct.doctubo maps the new words into the same feature space as training, and final LDA, new doc, returns the document topic mixture. Minimum probability equals 0.0 keeps all topic probabilities visible, which is helpful when you want to inspect mixtures rather than only the strongest assignment. Show topic then gives a few top words for the winning topic. The output shows the selected topic, its probability, and its words, connecting evaluation to a usable LDA prediction. A quick realism check. Swap the tiny docs for a 20 newsgroup subset, and the same steps still apply. You'll tune passes, iterations, and filtering more carefully for hundreds or thousands of documents to keep runtime and stability reasonable. In short, this is a practical, repeatable way to run Gensim LDA, compare num topics with CV coherence, and then apply the chosen model to new text. Use it to explore unlabeled text, build compact features, or summarize collections. One caveat: tokenization and filtering strongly shape results. So treat pre-processing as part of the model, not just plumbing. Try this next. Run the same pipeline on a mid-sized dataset, such as 20 newsgroups. Sweep num topics from 2 to 20 and pick the best value by CV coherence, while tuning passes to control stability. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.